Hello, this is Vincent Burnett of WonderCode Studios. Video games frequently have to render a large number of objects that each have their own material and geometry associated with them, and this can take a lot of CPU cycles that could be spent on other things such as AI and physics. And in fact, recent graphic APIs like DirectX 12 and Vulkan were introduced to reduce the amount of time that the CPU spends rendering different objects. Unfortunately, the results haven't been too good, and one of the reasons for this is because of the resource switching that's involved when you set a new material and the geometry needed to render a given object. So in this set of videos, we're going to explore different techniques to reduce the amount of time spent on rendering a set of multiple objects. And we're going to define that as batching. So in this term, batching will refer to, methods that reduce the amount of CPU cycles needed to render multiple objects. The first method we're going to consider is combining all the materials into one material using texture arrays, and we're going to consider using just one basic geometry, and then using tessellation and displacement maps to get the geometric variety from that. And so here we're going to consider this here object just a basic man object, and it has 6 surfaces plus the default surface, and we're going to consider this head, and we're going to export this head as a wavefront mesh object, and we're going to import it into ZBrush, and we're going to do some sculpting on it and some painting, and then we're going to export the displacement and normal maps and the texture and the color maps and import them into the game engine, and we're going to do it for various different sculpts. And for each object, we'll have some parameters which will be used to tell it what sculpt is appropriate for it and what materials textures are appropriate for it. And we're going to explore, how that can provide the scene variety that's needed to make a compelling game. Hello, I brought that head in as a wavefront object. I did some sculpting on it, and this is just one of the sculpts. And now I'm going to export it, and I'm going to be able to get the texture map, the displacement map, and the normal map. And I'll also be able to get the ambient occlusion map and the cavity map if I want. And then I'm going to export them out, and I'm going to bring them into my game engine, and then you'll be able to switch between different heads by just changing a little parameter on a given object. Here I've brought up my game engine, and I'm going to show you some of the maps that I got from the sculpts and ZBrush. Here's Nodaless. It's a node network displayer, and these node networks they contain nodes, and nodes are basically bits of shader code, and they all get compiled when they're done. Okay, so here you can see the heads, and we also have the displacement maps in the domain shader, but I'm not going to show you that. You'll see the results of it here. So Okay, so we're going to create one unit, and it's going to have a bunch of different agents in it. So it's going to have 66 different agents. Let's create a player type. Say that game unit for this in there. And now we're gonna create a campaign. Okay. There we are. Here we are. And you can see they kind of all have a little bit different combination. You can see there's various different heads, different arms, different shirts, different pants. And what are there? There's like 66 of them. You can go up here and see there's 66. You can see they all have the Man X material. Hi. So we saw how we could combine all the materials in one using texture arrays and have one mesh and use tessellation to kind of get a variety of geometry to get a variety of different characters. Now we're going to do that and show that we can do all that and render all those things in one draw call. Okay, so we're going to use this actor flex. These are flex buffers, I call them. And so we take this, put it, drag in the hierarchy. We're going to have to import a material. Okay, since it's using tessellation, I have to go there and I want to build that. And then now we're just setting up the creation parameters for the unit, and then we're just doing the same thing we did before. The when we create a unit, a bunch of actor objects will be created, but when those actor objects are rendered, the material will realize that the flex buffer is set, and it will automatically use a flex buffer for rendering, so that they all get rendered at the same time. If there's more objects rendered than the size of the parameters for this flex buffer, the maximum size of the flex buffer, then they will be rendered individually by the normal method. Okay, so all those are rendered in one draw call. And you can see they have different faces, different shirts and stuff, and pants, and I can get more variety there if I want to do the extra work. Just do more sculpting and painting and ZBrush, and then import them in. So that's about 90. It's about 500, 600. What's going on? Can't even see it's pretty responsive too. So how many we have here? We can just count them up. Oh, I've got about 700 there already. And that's about 1,000 characters. And you can see that I can move around, and all those characters are being rendered in one draw call. Okay, so you can see the potential for that.